Well, good morning again, everyone. We're going to go ahead and get started. First, thank you all for being here. I'm David Kiros. I'm the Assistant Division Chief of the Air Quality Planning and Science Division here at the California Air Resources Board, and we're really excited to present to all of you today the updates to the recreational marine vessels emissions inventory model. As many of you may know, this inventory has not been updated since 2014. It was a category that was previously called the pleasure craft model, and we're rebranding it as the recreational marine vessels inventory. Before we get started, I first want to recognize the lead staff who's been working tirelessly on this model update for the last several years, Daisy Wong. She's one of our senior inventory staff that has worked on a lot of gasoline off-road emissions inventory models and has dedicated the better part of the last decade to updating this source category. I also would like to recognize the team at the National Marine Manufacturers Association and MMA for their effort on coordinating with us and providing input on the survey that we're going to highlight today and was the basis of a lot of the updates that we presented. The survey was also conducted by our colleagues at the California State University, Fullerton. So I'd like to recognize Laura Gil Trejo, the director of the Social Science Research Center, whose team put a lot of effort into the survey development that went over this work. Before I turn things over to the manager of the section of the off-road gasoline inventory section to get things started, I want to highlight one thing about the scope of today's workshop. We are going to be providing an emissions inventory update only on this source category. The inventory models are what goes into our regional photochemical models to figure out emissions reductions opportunities and plan for achieving our air quality goals. What we're not going to be talking about today is any of the policy development, such as the concepts that were described in our 2022 state implementation plan strategy, where we had a target of going to the board in 2029 or so with some additional control measures. That is beyond the scope of what we're presenting today. This is just an inventory update. And if and when our partner division, the Mobile Source Control Division, works on those updates, a separate opportunity to update the inventory will also be possible. So this is not going to be necessarily the final inventory before any further action is taken on the category, and we're not going to be discussing any policy updates beyond the emissions inventory updates on where we think emissions are. With that, I'll turn things over to Lucas Algrim to get us started. Thank you all.
Great. Thanks, David. This is Lucas Hallgrim, the current manager of the section overseeing the RMV recreational marine vessel inventory. And I'll go ahead and start off the workshop just going over a little bit of a few housekeeping slides. So first off, I'll just note that we will have time for questions at the end of the presentation. If you do ask a question, please try to include the slide number if you're referring to a specific slide, just to help us hone in on what you're asking. And the questions can be added to the chat in the Zoom meeting during the presentation if you would like. We will not address them, though, during the presentation. We will go through to the end. And following the presentation, you can ask your question live by raising your hand in Zoom, or any questions in the chat we will also read over and address following the presentation. If you're on the phone, there's also a couple ways that you can ask a question by using the #2 function to raise your hand and using *6 to mute or unmute yourself. Additionally, we just want to note there is a 1-month question comment period following this workshop, and any additional questions you have can be submitted to us at this branch website, the msei@arv.ca.gov, as well as reaching out to Daisy or I directly. So next slide. So just a couple notes on this workshop. As I mentioned, you could be calling in. If you're on Zoom now, we just wanted to list the call in, meeting ID, and passcode needed to do that. These are also on the Zoom invite that you should have received. We'll note that the workshop is being recorded. We will ultimately post the recording to our website, and that's on our off-road conferences and workshops portion of our website. This was a one final point that David already touched on, but I'll just reiterate that this workshop is not intended to update any of the Spark Ignition Marine uh, engine emission reduction strategies that were introduced in our recent state SIP strategy. Will be very focused on just the inventory development. And with that, I will go ahead and turn it over to our lead staff, Daisy Wong, as she gets into the content of this presentation.
Thank you, Lucas. Good morning. I'm Daisy. So I'm the staff who work on this update of the RMV emission inventory. Today's presentation will start with a few slides of background. We'll talk about the general information about the RMV and the emission inventory. Then we're gonna spend quite a long time to talk about the survey and what's the survey finding and how we incorporate into our emission inventory. And then last, we're gonna talk about the Army's population update. So with the population update, there's also, because the population update is also linked to the emission factors update. So we'll spend some time on that one too. And then in the end, we'll present some of the emission results at the end of the presentation. So next slide. So this is just a general information about the recreational marine vessel. In our emission model, there's a total 6 types of emission RME categories. So this is in line with the DME registration, the type of vessels in the DME registration. Also, this is same type of categories in our certification database, which is submitted by the manufacturers, the marine engine manufacturers submit to the ARB. So we have this inboard stern drive, which their engines is fixed within the vessel. The inboard usually is in the middle, and then in the stern drive, the engines at the end of the boat. And then we have outboard and jet and the PWC, the jet ski, and also we have a very few small population in auxiliary cells. Yes. So to understand, this slide just outlines the framework of CARB used to build our emission inventory for the RMV. Then population, the profile, we categorize vessels by age, fuel type, and horsepower, and this is critical because the older engine has a very different emission profile than the modern fuel efficient engines. Then the activity, how many hours a year a vessel is actually running. So which months they're running. So this is all something that we need to build our emission inventory. And the emission rate. So it's how many grams per emission is being output from the engine. So this 3 is basic factors that to build any emission inventory. And then on top of that, then there's a geographic distribution, the allocation factor, we call that. And so we track where the boats are stored versus where they actually operate. So this to identify for localized air quality impacts. So when we put all 4 these factors, cornerstones together, so we'll get the emission inventory. So let's talk about the summary of those updated input data sources we use for this update. And of course, the survey. So the main purpose of the survey is to identify the allocation where the boats are operated in California and their activity, whether they're changed from last emission inventory. So that was more than 10 years ago. And the next one, the DME registration. So since the last update, we have 10 more extra years of DME data. So this tells us the age distribution attrition and how many new vessels introduced in every year and how many are retired from the fleet. So this is kind of important for the emission inventory. And then also we included the U.S. Coast Guard registration. We just realized there's some small portion of larger RMV boats are they register only with the U.S. Coast Guard. So we included this portion of the vessels into our emission inventory. And then we have 2022 UCOA's 10-year economic report. So this basically is a short-term forecasting growth. So basically we use this indicator to predict the annual sales, the new sales in the next few years. And then we have a SIME, which is Spark Ignition Marine Engine Database, and the PLT, which is the Production Line Test Report. These two databases are submitted, both submitted to ARB regularly by the marine engine manufacturers. So when we compile those data together, we'll get this database. So this database, we use this two database to update our exhaust zero-hour emission factors for NOx and HC, and also because there's a population, production population of the engines for those type of engine families. So the fuel technology, and the horsepower split, which go into the model, are all being derived from these two reports. Next one. Let's talk about the survey, the summary of the survey. So to ensure the unbiased and statistically sound results, then the CARB is partnered with Social Science Research Center and the Cal State University of Fullerton, basically for their academic partnership and their expert execution on the surveys. So our target audience is the survey recipients were verified the RMV owners identified directly through the official DMV registration data. So this ensures us talking to the actual stakeholders, not just some general public. Then let's talk about the surveys development process. So before the full launch, of course, there's a draft survey questions. So we refine those surveys, the draft survey question with a small group of 18 RMV owners to ensure the question were clear and capture the right technical details. So this 18 interviewees' answers are listed in the back of the RMV survey reports appendix, so which was also posted on our MSEI website. Then there's a pilot survey. So this is our 500 postcard we sent it out. This is essentially a dry run was to conduct it to test the logistics and the response quality before we committing to our full scale of the mailing. And then there's the main event. So the full survey was spent around 6 months from January to July of 2022. So we we mailed the 3 batches of postcards. In combined, it's over 85,000 postcards we sent it out. And in the end, we received over 2,800 complete survey responses. So this response rate is 3.33%. This is a standard and statistically significant response rate for a cold mail survey of this type of technical depth. So the big question is, how many people do we really need to hear from to accurately understand a population of over 100,000 vessel owners? Remember, the total vessel owners over 800. It means close to 800 vessel owners in California. 800,000, I'm sorry. So the baseline to achieve a standard 95% confidence level with a plus or minus 5% margin of error, we only technically need 384 responses. So our results, then you can see this reference table, we total received over 2,800 responses. So we're operating in the more precise 99% confidence level with a tiny 2% margin of error. So we need a 2,475 response, and we're passing that. So basically it tells us essentially the survey is operating in a more precise category. So it gives us a very extreme confidence in the data. So for those who are interested in the technical side, so this is a formula, it's called Cochrane's formula. Basically, it's a standard statistical equation used to determine the ideal sample size for a survey or research study when the population is very large or unknown. So this slide, it's a verification slide to prove the survey isn't just mathematically sound. That was the previous slide, but it's also geographically representative of all counties in California. So a common pitfall in a statewide survey is clustering. So we're getting too many responses from one area, say for example, such as South Coast, or not enough from another, maybe like Central Valley of California. So as you can see from the side-by-side bars, our survey response closely aligned, the orange ones closely aligned with the actual DMV registration, the blue bars, for every single counties in the state. So then let's look at those major hubs, the high density areas such as Los Angeles. There's total around 12% of the statewide boat population. The Orange County is about 7%, and San Diego's also 7%. So the survey response rate tracked with the registration population. And even in the small counties, which less than 1% of the total statewide vessel population, the survey maintained a proportionally representation. So basically, this proves that data we're using to build our emission inventory isn't skewed towards one specific boating culture or climate. It's represent the entire state's, California's diverse geography. So this tight correlation shows here, so serves as a stress test for our methodology. It confirms the mail list and a response collection were successful in capture the true cross-section of the California boaters. A common question is whether our emission model are too harsh because the model assumes, say, for example, a 20-year-old boat has a 20-year-old engine. To test this, we asked the question in a survey. Have you replaced, repowered, rebuilt the engine of the RMV? So the survey results showed that nearly 5,000 RMV engines, remember we're talking about we received over 2,800 survey response. some of those people have more than one vessel, and some of the vessels more than one engine. That's why you get the answer of almost 5,000 engines here. So of this almost 5,000 engines we received from the survey, we found that only 11% have actually been repowered or rebuilt. So within the 89% of the fleet are still running original equipment. So because of that, we decided to keep our model streamlined by tying emissions to the vessel's manufacture year. So as you can see from this is a historical gram of age distribution based on the 2021's DMV registration. So the data shows a mid-aged fleet. That means the mean age is 25.7 years. So with a significant concentration of vessel built between 15 to 35 years ago. So we're looking at this fleet, it's predominantly rely on older engine technology. Then we look at these two tails, we see a small spike in the very new vessels, like 0 to 5 years old. At the long tail end, so those are the legacy vessels that are 45 years plus. They're still in the population. What this to do for the modeling decision is, so after analyzing this 11% of repowering rate, so CARB has chosen not to reflect a difference between the engine age and the vessel year in the current emission model. The reason is because nearly 9 of the 10 vessels are still using the original year of the engine. And this is a background slide where we're going to talk about explain the models, how the model differentiates between the emissions from boats that are parked versus those that are in use. So when we look this one, this is example map of the LA County basin. So you see that in the middle of the basin, there's a boat there. So there's no water there, meaning this boat cannot run in their engine, right? However, so we're still counting because they have diurnal, some type of evaporative emissions. So specifically, it's diurnal and resting loss. Those two emission processes mainly due to the temperature change. So, and it's active and the inactive populations of both those boats, regardless of use or not, they all have some fuel stored in their fuel compartment. So we count the diurnal resting loss. Then we have this boats in the coastline. So that's where the waterways, the lakes and coastal areas. Those are active population, of course. So we're counting their exhaust emissions and the evaporative emissions, specifically the hot soak and running loss. Those are all ties to when the engine's in during operation. That's a background. So this is a slide to show where the boats leave and where they play, okay? So the survey results is from the vast majority of the California boaters, 78%, the boating is a local activity. The owner stores and operates their vessels within the same county boundaries. Say, look example like Sacramento, right? Well, let's look at the graph, the diagonal red line. So that represents a perfect one-to-one ratio where the storage equals the operation. So all those little dots is all 58 California counties. All the y-axis values, if you add all 58 of them, you add to 1. That's California, right? And the x-axis is storage allocation. All the 58 counties x-axis value add together to 1. So you see that counties like Sacramento, the line just on the red line means this county's voters have enough waterways, not too far from their home. They're just gonna operate. Most operate within their county line. Then let's look at the San Bernardino. So we highlighted San Bernardino. It's sit significantly above the red line. It has the largest axis of operation compared to its storage. So this tells us it's a destination county. People from the surrounding areas are bringing their boats here. So likely there's a Colorado River or some local lakes to use their boats, even they may not live there. Then let's look at San Diego and Orange County. So these two counties, they're sitting below the red line. In San Diego in particular, you see much higher storage than operation. So this maybe just suggests that the area act as a major fleet hub. So there's maybe a service center where the boats are kept year-round, but not necessarily operating regularly. Then we can look at the Angeles. So it's Los Angeles remains a heavyweight, right? In both storage and the operation, they almost 12%. So it's slightly below the 1-to-1 ratio. So, and then the 4 yellow dots we highlight here, those are the South Coast Air Base. So we just want to highlight that. And if there's one slide that shows that why the 2022 survey was so necessary, this is the slide. Okay, the boating pattern in California, they're not static. In the decade since our last major inventory update, we see a clear migration of our activity towards Southern California and the specific inland destination county we talked about earlier, San Bernardino. So when we compare the blue bars, the previous inventory, to the orange bars, that's our new model. We can see the LA and the Riverside become even more central to the state's boating activity. And so the top chart, it's the allocation shift. So you notice a significant increase in the storage allocation for Los Angeles and also Orange County in the RMV2026 data. So this reflects a growing concentration of vessel home bases in these major metropolitan hubs. And then the Northern California, some smaller counties, and then the Contra Costa and Alameda have seen some slight decrease or remain stable, and indicating its relatively southward shift in where the state fleet is physically kept. Then the bottom chart is we're looking at the operation allocation shift. So this is where the most dramatic changes appear. Los Angeles Riverside showing a massive spike in operation activity in the new model. So this suggests this area has seen much higher engine on time than the previously estimated. Then San Diego dip. So interestingly, so we're talking about San Diego remaining a major hub, but the operation allocation has decreased slightly compared to the previous model. So this basically just tells us the boating are stored here. There may be not operating here, or they're just not operating as we think they're operating in the previous model. So let's talk about the emission impact of this shift. This shift is not necessarily mean the total emissions have gone up. This just means we're now attribute those emissions to the correct counties where the much higher accuracy. So if you want to see where the 2022 survey data makes the biggest impact, so it's a South Coast Air Basin. Under the previous model, we were underestimating the boats where the boating were kept and where they're being used in Southern California. So the new model shows that South Coast Air Basin now accounts for over 30% of the statewide population and nearly 28% of its operation. And for the San Joaquin Valley, it's remained relatively stable. South Coast, let's look at the South Coast. It's basically a massive realignment, right? So we see a jump from the 15% to 27% for the operation allocation. So this indicates that nearly double the statewide operation activities occurred in this basin that we previously modeled. The storage allocation for South Coast so also climbed from 21% to 31%. So this suggests nearly 1/3 of all recreational vessels in California are home-based in South Coast Air Basin. San Joaquin Valley, the right side of the graph, shows a minor decrease in its shares in both statewide emissions. Operations dropped slightly from almost 14% to 12.5%. Then storage is dropped from 12% to 11%. So the interpretation of the San Joaquin Valley, it does not necessarily mean there are fewer boats in the valley, but it's the proportion of the statewide activity shift more towards the southern region. So this slide shows the survey result of the RMVs were actually used less. So this is the survey result of our 2022 survey across almost every boat category. So annual hours of on water dropped noticeably since the 2014 baseline. So in fact, it's 22% lower than our previous estimates. So it's important to, we just need to mention that the surveys happened during the COVID-19 pandemic. So we're combining the survey result and how much, because we also asked, So we asked the question about have people, the survey, have your activity decreased or increased compared to pre-pandemic? So the results also combine with people's answer on how many hours they've been operating. So this one is adjusted value for a more stable long-term baseline for regular California's boating activity. So adjust this is for the model wise, it's the adjustment, it's important for the new inventory. It suggests that previous model may have overestimated exhaust emissions by assuming boats run more hours per year than they actually do. Let's look at survival rate. The survival curve is derived from a DMV registration. The survival curve does not track how long a boat's engine lasts before it's breaking. It rather tracks how long a vessel remains registered in the California DMV system. So we discovered that California are holding their boats much longer than the previously thought, the model suggested. So if you look at the gap between the blue dashed line, the PC 2014, so we only have 6 years of DMV data, assuming a much faster retirement rate of the vessels. And the red line, So that's our new model. We have 10 more extra years of DMV data. So we are showing a significant upward shift. So when you see this longevity gap, this is essentially a boat built 30 years ago is twice as likely to still be on the water as we previously estimate. So for emission inventory or the air quality perspective, it means the older, higher emission technology engines stay in the fleet longer than we previously predicted. Then let's look at the peak in the first 5 years. This represents the period where the new vessels are most consistently registered. Then look at the age 30. The new model shows a survival percentage nearly double when we previously estimate. Then at the 60 years mark, there's a small and still extra measurable percentage of the outboard fleet still remain active. Why this matters to the emission inventory? Because the vessels stay in the system longer, the turnover to the newer, cleaner engine technology is happening more slowly than we previously thought. This slide is where we check our math against the real world. So this chart is a result of updating both of our total population counts, the DMV data, and our survival logic, how long the boats that stay in the service. So the comparison, we're looking at PC 2014, the blue line, which is our previous forecast, right? Versus the RMV2026, the solid red line. So that's the actual DMV registration as of calendar year 2021. So when we look at this, we can see that PC 2014's model will overestimate the annual sales in its forecast, particularly for the newer vessels age 0 to 10. Then the solid red line we're showing here, the fewer new vessels enter the fleet during this period than we originally predicted. This adjustment is allow us to right size the inventory, so we're not over calculating the emissions from vessels that do not actually exist in the fleet. Then you notice the red line and blue line, they're aligned much more closely for vessel age 15 to 40 years. So this confirms that our data for the core of the fleet, the mid-age boat, it's very stable. And then we're looking the age 45 to 60, the red line stay above the blue line. So this visually confirms what we discussed on the previous slide. The older vessels are survive longer than our PC 2014, the previous model assumed. So what this matter to the inventory? So we're moving from the forecast population, which in the previous model, to the actual registration, the new model. We're ensuring that emission calculation based on the real boats, not on the theoretically population projections. Let's talk about the population forecast. So now we right size our current population data. So then we have to look in the future. How many boats will be on California waters in 2030 or 2050? So to find out, we're looking at economic indicator. We found a strong link between the new home construction and the new boat sales, the correlation. So when we look at the historical data, and we analyzed the UCLA's their forecast. Then we found out there's strong statistically significant correlation, R squares equals 0.86, between the new boat sales and the building permit for single family house. Why is this connection? So when we think about recreational boats, they're discretionary items, luxury items, often tied to the home ownership and the household wealth, right? So the new house being built in the better economy means the vessel sales, it follow the similar trend. The near-term forecast, so the forecast next few years, so we rely on this UCLA forecast for the next 5 years, what the economy is going to be. Then the long-term forecasting, we're long-term forecasting towards the year 2050, we're shifting our focus based on the broader demographics. So the long-term projection were aligned with the California Department of Finance. So their projection of general population growth. So this near-term and long-term approach, so just ensures that 25 years emission outlook remain realistic. So accounts for the expected economic shift and also changing the population density in California. So to make our 2026 emission inventory update as complete as possible, we're looking beyond the California's DMV registration. So there's another whole class of larger, heavier boats. They're typically over 30 feet long in length and they're registered only with the U.S. Coast Guard. So when we look at the U.S. Coast Guard database, so we identify there's over 23,000 vessels that are registered only with U.S. Coast Guard, and it's a recreational purpose only and the California base. So this adjustment of population we're including into our this update emission inventory. And also remember this over 23,000 boats in the California. We also look whether if they're both registered both in the DMV and the U.S. Coast Guard. If those ones are double registered, we remove them from this adjustment factor. So when we talk to the U.S. Coast Guard representative, they said the U.S. Coast Guard's database, they do not list specifically what type of fuel, the engine type they're used, but they almost certain that over 30 feet and the weight over 5 tons, they're diesel engines. So for all the majority of the U.S. Coast Guard registered only boats, many of them fall into this category. Then so after analyze all the data, we have some type of adjustment. So the auxiliary cells and inboard stir drive. Then typically those are the bigger boats. They're capable go long range and offshore travels. So now we talk about the DMV registration update, and then we have our short-term and long-term forecast. Then we compare this population file in the previous model, the new models. So we can see in the immediate future, both PC 2014 and the RMV 2026, they show similar downward trend towards the total vessel population. So basically, we start the model, it's around 800,000 registered vessels in the California in 2022. Then we're looking at PC 2014, So this is a previous assumption. The older model, we project the fleet population would bottom out at around the year 2036. Then we think the population will start to steadily increase. Vessel population reach back probably to 700,000 till the year 2050. And this new model, we think, incorporate the new sales trends and the survival curves that we discussed and paint a different picture. So there's no recovery phase. Instead of rebound, we think the RMV2026 projects a sustained decline in the total vessel population through the year 2050, then stabilize around 550 units. So it's significantly lower than the 700,000 we previously anticipated. So what is this importance? The smaller fleet generally implies a lower total emission. But when you think about this, must be balanced against the fact that remaining vessels are stay in the fleet longer. So this is a question we have to think, right? So far we talk about the fundamental cornerstone, the three cornerstones of the emission inventory. We talk about the population. We talk about the activity. Then we talk about next. We're gonna talk about the emission factors. So the updated exhaust emission factor for the HC and NOx are directly from the certification database provided by the engine manufacturer to ARB. So the EO, the application EO, will list the 0-hour emission of HC and NOx, and also in let's say, for example, 500 hours. If the manufacturer say at 500 hours, in the 500 hours, what is the emission for the HC and NOx? So we got this 0-hour emission and the emission at hour X, right? So the shift in the weighting methodology. See, the old approach, the previous model, we rate the emission based on the projected production volume that's submitted to the same database, where the engine production volume were estimated by the engine manufacturer at the beginning of the year when they obtain their yield. And the new model, the RMV2026, so we're using the engine production line testing database. So this PLT, basically it's an actual production volume of the engine model for each calendar year. So this gives us a much more accurate reflection of what is truly being produced for the California's emission standard. So the importance of this is that we're correcting the bias using the actual population versus the projected population. We eliminate the risk of an over or underestimate emission based on the inaccurate manufacturer forecast. Next. So this slide reviews the direct impact of the decision of using the PLT instead of the same database. So our previous model, you see that for the 0-hour emission for the HC, so the left chart shows nearly all horsepower categories. It's a lower emission than the previous emissions inventories. And for the NOx, actually, other than the 25 horsepower, all the emission factors become higher. And then because, CARB is certified the emissions is HC plus NOx combined. So in the end, they're still meet under the emission standard. I was told this slide's too much information. We'll spend a little more time. So this update will also introduce a major shift of how we model the aging processing of the engine emissions by moving from the static model to one that include the deterioration factors. So we're acknowledging that the engine generally getting dirtier as they age, up to a specific age. So in our previous model, we use a flatline assumption. Essentially, we say this engines never get dirtier over time. So we know that's not true, right? So we also know that the emission does not increase forever. So we review all 6 vessel categories and every horsepower group. We found this a consistent plateau point. So we're going to cap that at 1,000 hours. So our new model follows this emission rise as the engine works through its primary useful life, which we cap at 1,000 hours. And then this is the new model's approach. Let's look at this one a little bit more careful. So the previous inventory exhaust emissions were modeled as a flat line. So that's what you see this y-axis at the 10. So we have this crossed out. We assume the engine emits the same amount of pollutant as first day, same as the first day and last day of its useful life. And then the new emission standard, so we incorporate the deterioration factor. So this reflects the reality that engine components wears down, then the emission levels typically will rise, right? So basically, this tells us that for the same piece of G4, gasoline 4-stroke, the fuel injection 50 horsepower, this piece of engine, in the previous model, the entire life, the emissions, it's this blue or green area, the rectangle area. And in the new model, so on top of that, because we include the deterioration factors, so on top of the additional, this trapezoid area, it's added to the additional. So basically in the new model, this piece of equipment have extra, let's say maybe 50% extra of emission for this specific piece of equipment. So because we moved to the PLT database, so we have the actual engine population. So we also re-evaluation what is being applied to all model years currently in the population. So we're give an example here. It's an inboard model year 2010. So after when we review all the database, we look at that previous model estimate diesel is made up 32% of inboard in the model year 2010 based on the estimated the engine production population. And the updated one, when we have the actual population, we're looking at the actual of diesel, it's become a diesel percentage becomes 16%. And also there's a rise of the fuel injection, which is a trend, right? You got the cleaner, more fuel efficient engines. So modern, cleaner 4-stroke gasoline fuel injection engines counts for 79% in this category, up for previously from the 68%. Then we also found some 5% older 4-stroke gasoline carbureted engines that previously were missed. Next one. So not only the fuel tech split, but also the horsepower split is also being updated because it's PLT. So this is an example of an inboard horsepower categories distribution. So in the previous model, remember, it's estimated production. So we have a lot horsepowers being allocated to the smaller horsepower group. But in this new model, when we see the actual production, all the small horsepower group are disappeared. So it shifted, starting in 175, very small amount, but largely it's 250. And then 375 horsepower is newly added because when we had meeting with the NMMA, they suggested we should have another horsepower group in between the previous 250 to 500. So we create the 375, I'm sorry. So then immediately you see this, the majority of almost 40% of the population is being allocated into the 375 horsepower group. So shifted previously, maybe it's in the 500 horsepower group, right? So this is a different shift. Just keep in mind, because a different horsepower group, you have a different emission factors. Everything's, because the population changed, so everything's changing accordingly. So this concludes the emission factor related changes. Next, we'll look at the statewide emissions results so far. Let's look at NOx first for the statewide summer NOx emissions. So everything we discussed today, the longer the boats, its survival rate, the longer lifespan, the newer added the deterioration factor, and the shifting from the actual population, and the updated emission factors. So first we're looking at this. Oh, okay, so the NOx stay flat, 20 tons. It's throughout from 2025 to 2037. But this flat line, when we think about it, actually it's good, right? It tells us the emission were gained by keeping older boats in the water longer, and almost perfect balance out by the fact that there are simply fewer new boats being sold. More important, it shows that the previous model was overestimating the NOx emission population as much as 13% more. So the upward pressure here when we look at this model, it's the first one, the higher survival rate, meaning that older, higher emitting engines stay in the fleet longer. Then the second factor, so this is upward pressure. The new addition of deterioration factor will add more emissions per engine. Then there's a downward pressure. So increase is largely offset by the declining of the total vessel population we projected that compared to the previous model. And when we look at the PC 2014, the older one, so we're overestimate the baseline. The previous model, PC 2014, forecast a decline from 23.4 ton per day in 2025 down to 21.9 ton per day by 2037. So right now, because at that time was an assumption, but right now we can say that it's a flawed assumption. So the prediction of the reduction was based on the lower survival rate, which we showed earlier, right? Which assume a faster turnover of older engine than our survey data have now shown. So it's a decline, it's artificially decline, it's not real decline. So basically it tells us the model has improved the accuracy. So although it's like a curve, it's flat, the NOx seems is flat in this new updated model, but it's lower than the NOx estimate than the older model. It's from 13% to 8% between the year 2025 to 2037. Now let's look at the ROG emissions. So starting in 2025, the RMV2026 model starts a higher baseline of 112 ton per day compared to the 104 ton per day in the old model. So this is not because the air is getting dirtier, but it's because the new model is finally captured the reality of the engine's deterioration and the fact that California hold the boats are longer than we estimated. So the initial increase is driven by the two. The first one is deterioration factor, right? So because we added the deterioration factors, engines getting dirtier as their age. And remember, we have a higher survival rate. There's more older engines in the fleet than we previously thought. And we're talking about the decline it have a faster decline than the previous model. So the new model projects a fall below the old model estimate around the year 2032. So this update, we also have the TV temperature RVP factors being updated, which have lowering ROG emissions slightly. Then also there's the other less activity than the previous model, but we will go over the reason why NOx stay flat while the ROG is decline much faster in the later slide. 33 and 34 will go over the reason for that. And then the long-term divergence, the widening gap between the two models in 2030 is largely influenced by the difference of population forecast. So remember, our new model, we predict the population will keep on declining, while the older model, we think the population will rebound. Next, we'll look at the PM25 2.5 emission. So this is our final statewide emission slide. Look the PM 2.5. This is a very encouraging slide. So if you think about it, we're adding extra Coast Guard registered boats, and they're mostly are diesel engines. So we think, oh, maybe the diesel is going to be, PM is going to increase. But however, remember, we adjust the population profile. There's actually less overall diesel engines in the new model. So overall, so it's 17% of diesel now down to 13%. And another reason is because, there's less activity we're talking about than the previously estimated. So both are driving force for making the emission just down. So by 2037, so the new model projects the PM 2.5 emission drop 2.2 ton per day. So this represents a 1 ton per day reduction compared to the older model. So it's roughly around 31% decrease in the PM25 pollution. And now Lucas will take the presentation to talk about the emission for South Coast and the reason why the ROG decreased much faster while the NOx stay flat. Lucas.
Thanks, Daisy. So first, we'll just show some of the updated emission values at an air basin level on this slide. We have 4 plots. The top 2 plots are for the South Coast Air Basin, and the bottom 2 are for the San Joaquin Valley Air Basin. The left side is ROG, and the right side is NOx. And so if you look at the top 2 plots, a key thing that we show is that for the South Coast Air Basin emissions, ROG and NOx, we are showing a very notable increase in the emissions in that region for the RMV 2026 update. And Daisy's touched on that quite a bit already in this presentation. That's really driven by the increase in activity in RMV 2026 for the South Coast Air Basin. That's informed by the 2022 RMV survey. And if you compare that to the two plots below for the San Joaquin Valley Air Basin, you can tell that there's not that substantial increase in the RMV 2026 update. If anything, a little decrease in that region's emissions. And then a second thing that I'll point out on these slides is that for the ROG emissions on both of the plots on the left side, there's generally a decreasing trend moving from 2025 to the future years up to 2037. Those ROG emissions are coming down. However, on the NOx plots on the right, they're much more level moving into the future years. We're not seeing that pull down on the NOx as much. And so we'll discuss why we're seeing ROG come down or is projected to come down, but not NOx. So you can go to the next slide. Sure. And so these plots that I'll show here are pulled from the South Coast Air Basin data, but it really applies at a statewide level. And what I'll show is these two plots of ROG and NOx effective fleet-wide emission factors. And if we split it out by these different tech groups and look at the two different calendar years of 2025 and in the future of 2037, there's not a big change in these effective emission factors. Generally, each pair of bars is fairly similar. But there's one important thing to know here, and that's for the G2 carb category, which is the two-stroke carbureted gasoline engines. On the left side, there's a very high ROG emission factor for that engine type. And on the right, there's a very relatively low NOx emission factor for G2 carb. So that's an important thing to note here. And we'll go to the next slide. And that specific technology group, the two-stroke carbureted engines on the left plot of population, decreases notably in future years. So this technology group or engine type is basically being kind of removed from the fleet over time. And so while a lot of these other groups, the population is staying relatively similar, that two-stroke carb is decreasing quite a bit. And because that is the tech group that has very high ROG emissions, but low NOx emissions, the net effect of this change in the right plot is that it's pulling down ROG emissions substantially with very little effect on NOx. So the kind of takeaway there is that this trend that Daisy had highlighted previously of ROG projected to come down but not NOx is largely driven by this G2 carbureted engine kind of being pushed out of the fleet over time. And that's the end of the overview of the workshop. And so I'll just end here first showing our contacts, our emails for myself and for Daisy on the bottom of the slide. And we'll have some time for questions and comments. And we'll highlight that there is a period over the next month when you can submit any questions or comments or feedback to us. And if you submit it in the next month, we'll be able to review and address those comments. And you can hop to the next slide, Butch. So again, you can reach out to us directly or after this workshop. Again, you can use our branch email listed here at msei@arb.ca.gov. and we'll take questions and comments now, or you can always submit your questions to us in the next 30 days after this workshop. And so, yeah, Butch will help us moderate any questions that come in now.
Good morning, everybody. So you have two options to ask questions. One, you can raise your hand, or two, you could use the chat box that's at the bottom of the presentation. We'll go by first-person basis. So the floor is open to anybody who has questions. I will unmute you so you can verbally say what you want to ask. So please do so whenever you're ready. Thank you. Okay, we have one for Emil. I'm going to unmute you, Emil. So go ahead. You can ask your question.
Yes, thank you for the presentation. It very interesting stuff, and I can see that you've done a lot of work on this. I had a question on, you talked about the retirement curve of the boats, and do you have a feel for what is the average retirement age of a boat, roughly?
Easy or?
I think there's a slide for the age distribution. So that basically shows like how in the calendar year 2021. Can you get to the slide?
Sure. Survival rate?
Yeah, go more. Age distribution.
Excuse me.
This one, that one. No, next one. Next one. Going forward. This one. Okay. So basically it tells us, even when there's a 60, there's still some vessels in there. So when you're talking about the average, I think your question is the average age. We usually don't do the average age of how the vessel's being in the model, at least we don't do that.
Yeah,
Go ahead.
I was just curious what the average age might be, because it ties back to this question that you're not considering repowering, and it at least
so in the model for other than the jet, it's 50, and the PWC is 40 years. So the four other category of vessels, they're 60 years old, meaning that after 60 years, even though they may still appeared in the DME registration, but that's a very tiny small amount of population overall. But in the model, we start to take them out as when they turn 60 years old for this boats.
Yeah, I understand. I think it's pretty rare to see a 60-year-old outboard on a boat, but I think also that 11% of people said they repowered. I guess that was across the different boat categories, and I'd say that is that correct?
Yeah, that's for on all type of vessels, regardless of what type.
Yeah, and I think that for a inboard type boat, it's probably more likely someone would like rebuild the engine once it gets old, especially if it's a diesel. They might like rebuild it instead of replacing. But for an outboard, it's very, very common to simply buy a new one and put it on there. I would say much higher than 11% of all outboard boats, but that's just my feeling here. That was a comment.
We can go back. I can go back to look the survey results, but basically, and the slide here is not showing the mean age for the people who say they replaced the engines. Actually, it's less than 25.7, which is the mean age of the entire fleet. So this suggests that people who replace the engine, rebuild the power, the ones who answer yes, they're not necessarily because the vessel, their engine's getting older, but maybe because they want more performance. They're upgrade the engine's horsepower. So maybe that's the reason, but we're not gonna say that for sure at this point.
Okay. Yeah. Thank you very much for your answer. Appreciate it.
Thank you.
Thank you, Emil. We do have another hand raised from Jeff. Jeff, I'm going to unmute you. Okay.
There we go. All right.
Yeah,
Thanks,
that's
David.
good.
Oh, thank you. Appreciate it. So, just had a couple questions here. So I was curious what's happening after 2037 because we're generally seeing our sales decreasing in California, and I was just curious with the new model. Go to slide. Let's see, where was this? Well, your HC and NOx, your reactive organic gases and NOx were relatively flat on NOx out to 2037. I'm just curious. Yeah, sorry, you just had it. Yeah, there you go. So the new model, so 2037 is kind of where it stopped. I'm assuming those numbers would continue to decrease slightly beyond 2037, or?
And the model, we released the model on our MSEI website. You actually can run the model yourself, but I believe the NOx is slightly decreasing, very small amount because we're talking about the majority of the population still mid-age. They're still holding on to the fleet population. So the NOx is not declining as much, and the ROC is declining. You can see the trend.
Okay, so the new model is live then? This
Yeah,
new
yes. Yeah.
Okay, awesome. Yeah, I'll play around with it.
Awesome. Thank you, Jeff. Appreciate you. And now, did you have another question, Jeff? Sorry.
I did have another question. So my question was with respect to slide 25. Daisy, you had brought that up where it was showing the deterioration factors and the rest. We want to pull that slide up. I was just curious how as typically manufacturers will certify, let's say the standard is roughly, I'll just call it 16 grams per kilowatt hour HC plus NOx. And typically manufacturers will certify below the standard. So I'll just make up a number, maybe 10 grams per kilowatt hour. So what you're doing in that case is you're applying the manufacturer's deterioration factor, or are you starting at the 16 gram per kilowatt hour and then adding? I guess I wasn't sure because I'm looking at grams per brake horsepower hour, so I'm not doing the math in my head here. But how are you taking the emission factors in the new model? Are they based on certification values of engines, or are they based on the standard?
So in the model, we'll have the hour zero, right? So your hour zeros, it's emission factors. That's like, for example, it's 10 grams HC plus NOx together, right? So for the first 1,000 hours of the engine's life, which is, let's say it's around first 20 years of the engines being operating, the emission factor every year will increase slightly. So the rate of increase, that it's that slope you're seeing from 0 to 1,000 hours, the vertical line, the first 1,000 hours, we cap that. Once in the model, once beyond that point, because when we're saying the engines last for 60 years, right? So the useful life starting at an hour, let's say year 21, it'll start being flat. So the emission factor, exhaust emission factor for this engine is going to be same as year 20's emission factor. So any time beyond 1,000 hours, the exhaust emission factor will stay same as the 1,000. So we're not going to keep on increasing indefinitely, which is the diagonal line you see. We're not going to increase like that. We just, in the model, it's going to stay flat as, let's say, 12 hours, gram per brake horse line, that there. So that's in the model.
Okay.
And Jeff, this is David Kira. So
Hey, David.
we start the emissions rate at the level the engine was certified, not at the standard. So in this slide that you see, there's that dashed horizontal red line that's somewhere between 12 and 13 across the whole plot. That's the standard, but we start at the axis around 10 grams per brake horsepower hour, and then just follow that orange triangle up until it flattens out, as Daisy said.
Oh, I see. So it is based on the manufacturer's certification value and their deterioration factor. Okay.
Yes.
Correct.
Okay. Thank you.
We do
you.
think there's an opportunity to do more in-use testing just to see what deterioration actually is of a 20-year-old engine or 1,000-hour operated engine. But in absence of having that data, we just defer to the certification level and then the manufacturer submitted deterioration rate.
Okay. Thanks for the clarification. Appreciate it.
Thank you, Jeff. Was there a last question? You're okay. You're good? Okay. We're switching over to Sarah Roberts. How are you? Thank you for asking a question. I'll unmute you and ask away.
Hi, thank you. Sarah Roberts, U.S. EPA Office of Transportation and Air Quality. Thanks so much for sharing this work. And I think my question was answered in the previous round. I was going to ask you to talk a little bit more about the model itself, including if it was a software package that would be available publicly along with input data.
Yes, the input data and the entire the model, it's online on the MSCI website right now. So you have this input data package. It's all in there.
Thank you.
Yeah, and just to add to that, Sarah, that it is actually a zip file. So when you uncompress it, you'll actually have an input folder, an output folder, and the actual executable for the RMV 2026 model. Just to let you know.
Sounds great.
Yeah.
Thanks so much.
You're welcome. Hey, Emil is back.
Yeah, since you stopped on this slide, I just noticed something here. It says median age 1,357, average age 1,416 hours, and half-life 1,770 hours. Are those the actual like engine hours that the model is assuming, or what are those?
Those are is just like we want to demonstrate the idea. So those are sort of like a few significant lines like that in the model, but we're not using that. This slide is just like a demonstrate the idea of how we make the decision of the cap at 1,000 hours.
So the average age of a 50 horsepower outboard is not 1,416 hours in the model.
It's just purely like because we're assuming the 60 years for the outboard engine, and then the use the annual activity for the I believe it's 52 something around there hours per year. So that's just purely like a 52 times 60, and then all those are median life. And then all those are being the median life. It's from the model from the entire population when we look at that. But those are just purely the demonstration of compared to the what we capped at 1,000 hours versus what is really happened in the model.
Okay, but so they are kind of representative of what the model assumes.
Yes.
Yeah,
yes.
that those numbers are extremely high, I would say, for an engine like that. It would I don't know. I think that's a very high number anyway. Yeah. Thank you.
Thank you, Emil. The floor is open to anybody else who has any more questions, as well as the chat. You have that option as well. Michelle. And Michelle, go ahead.
Hi.
There.
Sorry, I was on mute. I have a question about slide 20. I was wondering why you chose to fit it to a logarithmic curve rather than linear, and also if you looked at any other correlations rather than building permits.
Yes. Okay. I guess there's two questions. So I'm gonna ask whether we look at the all other ones. The UCLA that the reports have over 100 like economic matrix. Basically, we actually write a little software to compare every single one of them. So then this single family unit, that's the best R square we're getting. And the second question is why we use the log curve versus, say, for example, a straight line. So the log curve, I think, I think anytime in the real world, I think the log curve it's a better real world prediction than the straight line. And actually, the PC 2014, that one actually did use a straight line approach, which actually, by now we know it's overestimating the growth, and also we predicted a much higher the lower survival. So I think it's the model itself is keep on like readjusting whatever the best fitted line that give the best R square. That's the one we're gonna use. And also remember, this is a short-term forecast of just for the next 5 year growth. So the next model update, we'll see whether this is going to be the best fit or not. But keep in mind, this graph is from year 2009 to 2019. So we're not including the year 2008, which is the Great Recession time, and also year 2020 and 2021, which is the COVID time. So if we include those two lines together, which is something happens unpredictably and no one knows, those will throw off the curve a lot. So, but by normal predicting, we're decide to exclude those two ends, which something no one knows going to happen. So during a regular time, this is better. That's for forecasting purpose.
Okay, and then these single family unit permits, are they for new properties or do they also include replacement of old homes that were torn down?
That I'm not sure what the data source the UCLA getting, but we can follow up with the UCLA. But I believe that's a single family unit. That's probably, I would say it's including any ones being torn down to rebuild as entirely new, but not the remodeling type.
Okay.
And just to follow on that, Michelle, you can, that's something that we can look into to be sure of and follow up with you. And you could submit that question to us as well in the next, over this comment period, just to be sure that we get back to you on it.
Okay. Yeah, I was just curious if it's supposed to reflect population growth, because that's what it seems like it's supposed to be doing.
Thank you, Michelle. Okay. If anybody else want to ask a question, the floor is open to you. Both chat or raise your hand, please. Okay, so I see Archana Agrawal sending a text, or excuse me, a chat message, and her question is, there are non-recreational vessels that are gasoline powered. Are there any plans to include those in CARB's marine vessels inventory, either under hovercraft, or other marine vessel category?
We'll have David to answer that question.
Well, I think they're asking about anything other than gasoline, and we do currently have diesel, small fraction in this inventory. So we'll note that we do cover some of these non-gasoline powered vessels. On some of the last few slides of the presentation where we separate them out by the tech groups, you'll see there was a diesel category there as well. Yeah, so we are capturing some of the non-gasoline vessels.
And this is David Kiros. I'll add one more thing because the commercial hovercraft sector was mentioned. That even though they're both rec marine and hovercraft are closely related in some aspects, it's a different section in our division that handles it. But extending even further, we have the rec marine, we have hovercraft, and then we have ocean-going vessels. And the way we divvy up the inventory is that every vessel should belong in uniquely one of those categories, and there should be nothing missing, and there should be no overlap between the categories. We generally think of recreational vessels as gasoline powered, but as Lucas said, and we heard in the presentation, there are some diesel recreational vessels. And then in the hovercraft sector, that's mostly going to be diesel powered commercial vessels, but there are some vessels that are used that do have gasoline engines that are subject to that rule. So there's not perfect dividing lines, but from an inventory perspective, it is our intent and our understanding that each of the three sectors have a vessel in uniquely one of the inventories, and there's nothing missing and no overlap. And so if you have any further refinements or comments on how we did that, we're happy to discuss further and dig into the methodology to make sure we're not missing something.
Thank you, Archana, for your question on chat. Anybody else have questions? Floor is yours. Okay, looks like, sorry.
Maybe while we're waiting, I'll just add one quick follow-up comment to Sarah Roberts, who had asked about the model and being able to download and use it. I'll just mention that to note that when you do download that from our website, it can be, there's certain things like you may need to have it on your C drive to run it, and you may need to change some of the properties of the file to get it to run. So just be sure that please do download and play with it and let us know your thoughts. And if you have any issues getting it to run, please reach out to us immediately, and we'll help you to be sure that you can change any of the properties as needed to get that to work, and so that you can have time to play with that in this 30-day comment period.
Right. Thank you, Lucas. There are no other hands up at this point, but I'll give it a few more seconds just in case. Yay. Rui, thank you. I will go ahead and ask your question.
Hi, can you hear me?
Yes, thank you.
This is Ray Zhang from South Coast AQMD. First of all, thank you so much, Lucas and Daisy, to reach us about the topic with the inventory change for South Coast portion. So there is a slide, and like for this study and the previous one, the South Coast emission portion is significantly increased, right? Almost double. And then one thing is you said you have the continuously DMV data from 2006 to 2021. And I just wonder if you see this trend also from this DMV data for the portion of South Coast versus the whole states. Because Stacy, in the presentation, you said this is a big alignment for these updates compared to the last run, right? For the South Coast portion.
It's the slide where the comparison of allocation, the first,
Okay.
the back, yeah, have the top and bottom, that one.
That one.
So remember where we're talking about when we conduct a survey, whether there's one for the statewide survey, whether you got too many answer from one part of the state versus another part of the state, you didn't have enough answer. The way we, of course, back then this is actually discovered in our tech memo, which is also in our website. The previous survey, we have 1,100 participants, and that was a phone survey. So we talk about during this survey that we actually proportion the DME registration. Like in South Coast, there's a 12% of population. So we make sure there's a 12% of the survey all from the South Coast region. LA County, for example, in this case. And in the previous survey, where at the time the technology wasn't there, and it just randomly selected survey participants. And also the people, the phone service, not everyone's going to pick up the phone to answer a question. So the people in the previous survey, there's a disproportionately large amount of people from the Northern California answer a survey. Specifically, is I think it's San Francisco area. There's disproportionate large amount of people answer from Northern California than in the Southern California. So the allocation factor was overestimated in the Northern California at the time and underestimated for the Southern California at the time. So that's for the allocation factors in the previous model. And also for the storage allocation factor in the previous model. That one was counting the marina slips in each county. So for this, so for now, we know that there's a large amount from the survey result, 78% of people, they say they parked their RMVs in front of a driveway or something. Not everyone have their boats in the marina. So for that reason, the order of the PC 2014's storage allocation also is skewed by which county has more marina slips. So in this survey, we make sure we remove all this bias. So this, not saying the previous ones were wrong, but it's also because it's a limitation at the time. But in this survey, we correct all those bias and have an accurate representation for the South Coast Air Basin. And this update.
Thank you. So I think I have another follow-up is like for the trend for the South Coast Air Basin, the slide 31. We have a decreasing trend for the rock and a flat trend for the NOx. And I see a previous slide for the statewide, there is a decreasing trend for direct PM 2.5 emissions. So how about for South Coast, the trend for the PM? Is it still decreasing or is it relatively flat? I guess we can play with the model when it's released.
It is released, but I'll happy to help you run a model to give you the answer for that one, for the PM for the South Coast Air Basin.
Yeah, so I think for our concern is because we are in charge to doing the SIP demo, and now with this new comprehensive emission updates, and we have more portion of the state emissions, and we have more NOx to work with. I think this is more related to the David, and the beginning. He mentioned their CARB may do some control strategy relate to this emission category for that?
Well, this is David. I can clarify. Our 2022 state SIP strategy did have a measure that would be going to the board, I believe, in 2029 with additional controls for combustion, tighter combustion standards, and some zero emission requirements for the smallest engines. However, we're not talking about that today. The team that works on that is in a different division. They have not provided any information in the public realm that would differ from what's in the state SIP strategy. And we echoed those messages at our board presentation last week, where we gave an update on criteria pollutant planning. So nothing in the forecast here includes any additional controls, and it's not something that we're actively talking about in this workshop.
But with this new update of the emission baseline, consider the trend. Will CARB initiate a certain control measures for this category?
Not due to these updates.
Okay.
There might be some SIP modeling that's done for revisions to different standards and areas in the coming years that would be using this inventory, along with the other inventory updates for district reported sources and for area sources.
Okay. Thank you. That's all. Thank you so much.
Yeah, thanks,
Thank
Ray,
you.
for your questions.
Hey. No.
I think with that, then we're not seeing any new questions. We'll go ahead and conclude the workshop here. We want to just thank everyone again for joining. And please remember, there's the 30-day comment period. You can review these slides and the model on our website and reach out to us with any comments or feedback that you have. And we'll be really happy to see and review and address any comments that you can get to us in that next 30-day time period. Thank you again.
Thank you, everybody.
Thank you.